So for number 6 here, we have a real mess, right? It says customer service received an order for an area 2x squared plus 12x plus 13. Help them figure out an equivalent expression for the area using the diagram. So using the diagram is going to be the easiest thing to do, but it is a real mess, right? So the idea here is we still have to have perfect squares. So how many squares am I going to have? Well, the 2x squared tells me I'm going to have 2 squares. I'm going to just put them over here. Okay? Now, how many of these do I have to distribute? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So if I have 12, each of them gets 6. How many am I going to put on each side? I'm going to put 3. Okay, 1, 2, 3, and so on. So if I do that to both of these, right, how many little ones do they give me? They give me right here, I have, if I'm not mistaken, it's 13 little ones. But when we look at the diagram to complete the square, how many do I need? Right, I have 3 rows by 3, which tells me I need 9 here, and then I would need 9 here. So I need 18. Okay, but I only have 13 to distribute. Okay, so right now when we look at this, right, this 2x squared plus 12x plus 13, what it distributes to is we get 2, let's do it over here. You get 2, all right, times x plus 3 all squared. But what you have to understand is, if I only had 13 here, how many did I have to add to complete the square? I had to add 5, which means if I added 5 to complete the square on one of these, because I was 5 short, to keep it equal, I have to go and subtract 5. I know that may sound confusing, but here's what it's doing. Is we have 2x squared plus 12x. Now, plus 13. If I break it up into perfect squares, I have 2 times, how many x squareds did I have in each? 1. And how many x squareds did I have in the other? 6. If we complete the square on this part, if I take 6, I divide it by 2, I get 3. Right? Outside here, I have the plus 13. Now, if I take 3 and I square it, I get 9. So to complete the square, I have to have 9. Which means I have 2x squared plus 12x plus 18. But if I added 18, right, to keep it equal, I have to subtract 18. And what is 13 minus 18? 5. So this is the equivalent expression that you would use. So do me a favor, try number 7 on your own, okay? Understand you have to distribute these, right, the squares into rectangles evenly, and then complete the square and see if you have an abundance or a shortage, okay? Pause the video and try number 7 now. Okay, let's take a look at number 7 now. We have 3 squares here. So we know we have 3 like such. Here I have 6 of these. So if I divide that by 3, each of them get 2, and if I make this square, 1 goes on each side. Now, if we wanted to complete this square, how many do I have to have in each of these corners? 3. So right now, if I look, we know this is x plus 1. But what did I have here? I have 3. I have 1, 2, 3 fulfilled. But how many do I have left over? I have 7. So when I look at this, a of x is equal to, I have 3, and if I look at the area of these, it's x plus 1 all squared. But how many did I have left over? I still had this plus 7 left over. Okay, now how do we figure this out algebraically? If we take what we had, right, with 3x squared plus 6x plus 10. Now, what I'm going to do is focus my attention here and complete the square. So how many squares did I end up making? 3. And how many x squareds did I have in each? 1. How many x's did I have in each? I had 2. So what do I have to add here to complete the square? Take half of b and square it, which gives me 1 squared, which is I'd have to add 1. But remember, adding 1 here, when I redistribute to 3, how many did I truly add? I truly added 3, so I have to subtract 3 on the outside here. So this would become 3 times this factors to x plus 1 all squared. Then what is 10 minus 3? Plus 7. So this is the equivalent expression once you complete the square. Do your best for homework. Your homework is going to be number 8, all of them. You could draw the diagram to help you out or do it algebraically.